Yeah. So what I want to talk about today really builds up, Chris. So where you left your talk on the opportunity and the responsibility ahead of us. I want to talk about the 99% problems. I am excited about working at geospatial data and Earth data, and development seed works with this data because we see it as the area where there's the greatest delta between the potential of this information and the actual application to everyday problems. 99% of problems that could benefit from Earth data and geospatial data aren't using that data today because it is hard to work with. And that will continue to be the case for as long as the decision-making workflow can't accommodate our current tools and ways of working with that information. If your decision, if your ability to use geospatial data requires tasking a GIS unit to come up with some sort of analysis for you, 99% of problems won't use that data. If it requires downloading the entire Landsat archive to your university's high-performing compute cluster, like it won't use that data. So, and these are decisions that really matter. Like these are decisions that millions of farmers are making every day that impact our ability to sustainably feed the planet, and decisions that people, individuals, are making every day that will impact what our climate looks like in the next decade and how we respond to that. So these are important problems, and I think like everybody here, to skip ahead a bit, is kind of aligned on the potential of the cloud, the scale, the availability of massive amounts of data next to compute, next to really good distribution mechanisms to make this data more readily available and to essentially like weather appify more aspects of knowledge about the Earth. So when people want to get questions, they don't even necessarily know the data that's being consulted underneath. They're getting answers to their underlying questions. In order for us to get to that future, a lot of people need to work differently. We need to collect data differently, manage data differently, process it differently, do science differently, do speech differently. A lot of that work will be done differently by by government institutions, by four-letter agencies like NASA, USGS, and NOAA. I think Jonathan did a really nice job talking about where NOAA is on this, and a lot of what I'm going to talk about today is looking at more on the USGS and primarily on the NASA side on where those institutions are and in transitioning towards a cloud-native future. To be very clear, I do not work for or represent any of those entities. These are my own observations as a group that does work with a lot of those groups, and it is a ardent supporter of the folks within those organizations that are really pushing their own agencies to do better in this area. I think that's another part of my call here for everyone else is that we have a responsibility to make their job easier to do the thing that a lot of people within that organization want to do anyway. And so I think there's a recognition within agencies, not only of the, you see the graph here, the need in terms of the amount of data, but also the opportunity that exists, the potential that exists for making data available in different ways that extend beyond old modes and patterns for making data available, and significantly increase the societal benefit of this data. And so, the group that we work with within NASA the most, the NASA Impact, which is the implementation and advanced concept team, their mandate is to increase the societal impact of NASA's data, and a significant amount of their effort and budget is around developing cloud-native tools and infrastructure that will leverage the fact that NASA is moving in that direction to accelerate science and accelerate the availability of insights from NASA data. So, things that need to, that agencies need to do, certainly making more data available. I think agencies are already doing a lot of work to support the ecosystem of tooling and open source tooling in particular around this data, so that once it's out there, that it's easier to work with, and to help traditional users like the science community make that transition, and also sort of evolving their own data systems in order to build for a cloud native future for the ground up. on our side, I think it's important for us to acknowledge that, to like give credit where credit is due when agencies are doing that well. It's going to be tricky for them because of the way that they take credit for the usage of their data is going to be harder to track in some ways or different to track in some ways. And so the more you can be very public about how this is benefiting you and where you're using NASA data, the easier it will be, or NOAA and others, the easier it will be for them to justify the effort and expense that they're making in this. So it's a reminder to the community as well. The other thing I want to sort of point out, an emerging term of art, ARCO, is analysis ready, cloud optimized. This is sort of the combines both the cloud nativeness of the data, but also the ability to do analysis across an entire collection or multi collections that that is comparable, where you have comparable pixels or comparable data in a way that lends itself to analysis. So a few of the things that I will highlight, I think this one's already been mentioned quite a bit. This is the USGS has released collection 2 of Landsat data, fully COG stack, that has allowed us to build a new version, or to contribute to a new version of Landsat Look, which uses all the technology we talked about previously to allow users to define how they want to look at the Earth and to begin to get insights out of Landsat data immediately. One of the other things that we're working on is a harmonized Landsat Sentinel product, which is quietly one of the most valuable data sets that exists about the planet. Combines in a comparable way Landsat and Sentinel data so that you have a much more frequent revisit as new satellites go up, or as Landsat 9 data comes online, as other Sentinel-2 satellites come online. Eventually that'll get to the point where you have daily coverage of the entire planet at 30-meter resolution, but daily coverage for free. And that's an incredibly powerful product. And that data in itself is interesting, but it is also interesting in the way that we're using the cloud native technologies in order to support that. It is being produced on the cloud. The data itself is being distributed in COG and stack formats, and it is being used in NASA's own products are utilizing that infrastructure because we have co-located tiling and compute next to it, so that it can serve up that data into existing NASA products. So here's an example of that data being pulled into the fire risk firms tool that NASA uses for providing information on current fires. So that's providing near real-time information drawn directly from the HLS data set. But actually, before I get to JEDI, so another thing, I don't have a slide for it, but I think another thing that's really interesting is on the metadata side. There's a lot of really good work going on metadata. I'll just make a plug for some of the stuff that Matt and from LLM84 and that team will hopefully talk about at some point on how you combine NASA's existing metadata standard, like the CMS, or CMR, excuse me, which they use for their 1% problems, like the existing incumbents, and is really important there with Stack and other ways of making this data available for application use. On the map side, this is a tool for providing biomass researchers with the data that they need. Again, JEDI, the ESA Biomass Mission, and ISAR break the old way of downloading data and doing it on desktop. The volumes are just incredible. And so this is a Pathfinder program within NASA Impact to empower biomass researchers to better work with this data. For me, there are two things that are interesting that have come out of that. One is the collaborative nature of research that it allows. So it's not just that now I can do processing in a scale. It's like my workbench, the Pangeo-based workbench that I'm working on, I can share that with another researcher at another university. It's easier to replicate that work. It's easier to collaborate on that work. It's a really neat pattern that didn't exist in our old ways of dealing with this data that emerges. The other thing is the transition from research to productization of that data is a lot faster now because it's all off of the same infrastructure. When you have an algorithm that you develop that's gotten to a point of maturity that it's worth producing on a regular basis, the cost of that transition is so much lower that it makes viable data products that might not have been economically viable previously. I know I'm still on it. So dashboard, this is a set of tools for making that data, publishing that data to decision makers, which starts to get us towards the application of this data. And then I'll just say one project that's forthcoming that extends that even further is a project called Beta. This is a new effort that will essentially create the global, a sort of Earth mission control in a box. So if I care about the status of deforestation or waterways or population and movement of things and people, I can create a mission control where the science around that feeds into decision maker interfaces that you could actually, the instrumentation of that data in a way that you could have a mission control that is building up that same data analysis, and it all exists in a common ecosystem. I will leave it at that. Again, just one more shout out for the really great work at NASA Impact. And if you have other questions on this, Amy Barchauskas, who's involved in one of the later Q&A sessions, knows more about all of this than I do, so ask her.
Awesome. Thanks so much, Ian.